Welcome, everyone, to the Intel Network Builders webinar program. Thank you for taking the time to join us today for our presentation titled ADLINK Launches New Open Modular Architecture for COTS Platform. Before we get started, I want to point out some of the features of the BrightTalk tool that may improve your experience. There is a questions tab below your viewer. I encourage our live audience to please ask questions at any time. Our presenters will hold answering them until the end of the presentation. Below your viewing screen, you will also find an attachments tab with an additional documentation and reference materials, including a number of websites and documents mentioned in the presentation. Finally, at the end of the presentation, please take the time to provide feedback using the rating tab. We value your thoughts and will use the information to improve our future webinars. Intel Network Builders webinar series takes place live every week, so check the channel to see what is upcoming and access our growing library of recorded content. In addition to the resources you see here, we also offer a comprehensive NFP and SNDN training program through Intel Network Builders University. You can find this program at networkbuilders.intel.com/university. Today we are pleased to welcome Jeff Sharp. Located in Portland, Oregon, Jeff Sharp is the Senior Product Manager for ADLINK's Network and Communications portfolio focused on product strategies for the NFP, SNDN, MEC, and IoT markets. Jeff has over 33 years of telecom and communications experience focusing on network evolution strategy and product delivery. Prior to ADLINK, Jeff was Senior Manager of Solutions at Radius and Managing Director of Next Generation Platform Products at Nortel Networks. Welcome, Jeff, and thank you for taking the time to join us today.
Thank you, Renee, and I'm looking forward to announcing this great product of ours. So welcome, everyone. Whether time zone you're in, whether you're in North America, Europe, or Asia, I'm going to talk a little bit about a new platform that ADLINK pre-announced back in March, and we're rolling this out today. The product line is called Modular Industrial Cloud Architecture, or MICA for short. Everything has to have an acronym these days, so the product portfolio is called MICA. And to kind of give you a little bit of insight on who ADLINK is, ADLINK is not a super well-known brand throughout the industry, mainly because we're an embedded company. Over the past 21 years, we've been around building products for companies such as Ericsson and Boeing, Foxconn, and others. So we're actually built into many of the systems that we use today. That's part of the telecom market, the military, transportation, those type of markets that really need extreme rugged equipment, especially in the telecom market, where if you look at over the past 20, 30 years, the telecom market needs the NEBS compliant products, the rugged DC powered products that are distributed throughout mobile and telecom environments. And we use the DNA of the early days of ADLINK as an ODM provider on where we're actually building platforms. Over the past 5 to 6 years, we're more focused on platform delivery, both from a server perspective, IoT gateways, overall computer systems versus individual boards. So we've got a lot of good DNA in our bloodstream, and with a huge focus on platforms and white box for COTS, especially in the telecom market, we're seeing huge growth and growth potentials over the next few years. Just to kind of let you know, we're a worldwide company, of course. We're a manufacturer. We have manufacturing facilities in China and Shanghai, and also in Taipei, which is where our headquarters are. Here in North America, our headquarters is based out of San Jose. We have a huge integration facility. We also do some manufacturing in San Jose, and supporting all of the North America customers here in San Jose. And in Europe, we have sales offices and integration centers located throughout Europe. We have in London. Our European headquarters is located in Germany, in Mannheim. We have a huge facility and growing in Tel Aviv. Israel is a growing market for us. And then, of course, in Asia, we have sales and integration centers located in Singapore, Shenzhen, Beijing, and elsewhere. So we're not a small company. You know, we're growing. We have well over 1,800 employees, focusing mainly in engineering and R&D. We're focused on the future, and we're building a lot of new products. We see specific industries growing that we're meeting that challenge. We are a publicly traded company, and Jim Liu, our CEO, has been around actually since day one, a true visionary and a really great CEO for our company. Transitioning into the product, we have this Modular Industrial Cloud Architecture, which I mentioned earlier, was announced back in March time period. Up on ADLINK's website, adlinktech.com, you'll find a pull-down tab that shows MICA. We have white papers, webinars, product photos, data sheets, and whatnot on this product. But the key reason for the development of MICA is primarily driven by multiple facets of the growing telecom industry, especially for networking communications. And because ADLINK is focused primarily on end-to-end solutions for our customer base, and our customers are a few. They're the operators themselves looking for white box components. They're the telecom equipment manufacturing suppliers. And because of the telecom cloud architecture with NFP, SNDN, and mobile edge compute, we're seeing more and more application-based companies looking for more mobile edge technologies. And these include things like network security, DDoS, IPsec, next generation firewall, IDS, IPS, deep packet inspection, things like lawful intercept capabilities, CALIA, traffic management, traffic load balancing, packet and traffic flow capabilities, things that really need a lot of I/O and CPU power. Overall telecom network solutions, both from an EPC, MME, serving gateway, packet gateway, all the way to the virtual BTS or eNode B. Virtual CPE is another growing environment, especially for operators to grow and monetize their network for revenue generating opportunities, mainly for mobile edge compute-based technologies, which I'll go into a little bit more detail. Another area that we've focused a lot of energies over the last few years, especially with MICA, is video streaming and transcoding. Having the ability to have high-performing video and media servers is critical, especially at the edge, and not putting a lot of this gear up in the data center environment due to latency and backhaul capabilities. And as we start transitioning into the 5G arena, the use cases for video is exponentially increasing in the network. Mobile edge computing, we're seeing ourselves as one of the leaders in the mobile edge, or MEC for short, especially in outdoor servers and central office server systems like the MICA product. We have a very large ecosystem of partners, which also enables software porting onto our MICA and edge-based products. And then, of course, IoT and analytics. As IoT is becoming more of a forefront of technology for the telecom industry, MICA and our outdoor servers are gaining a lot of traction and proof of concepts. And we also have a large ecosystem of partners as well. Having that network overview, what we're also seeing, and I think a lot of our customers, especially the carriers, are seeing, is really an overall convergence of technologies. If you look at the mobile network and the cable networks, the internet providers, satellite providers, you're really seeing a convergence of companies. You're seeing a convergence of technologies in which common platforms and common compute is really becoming a major requirement. We're seeing a shift from more proprietary-based hardware, proprietary-based software, evolving into more of an off-the-shelf, non-custom, although COTS these days is considered a custom off-the-shelf because everyone tweaks things a bit. But we're really seeing this convergence of technologies, not just in the telecom mobile space, but also in the industrial markets. You know, defense is starting to use things like LTE and network-in-a-box technologies for command and control and battlefield technologies. We're using more and more off-the-shelf and proven technologies. Mining and industry, industrial applications for offshore drilling, fracking systems, things that are up in the Canadian tundra or Siberian environments that need rugged environment but want off-the-shelf systems, and they want the same technologies as the mobile networks. Transportation, and of course enterprise and venues are huge monetized environments that the operators can make money on. And we're seeing that convergence of technology. A great example is with that convergence, we're seeing the NFP and SNDN. It's the buzzword that we've been hearing over the past 5 to 6 years. Unfortunately, we would like to see more and more live deployments of NFP and SNDN. We're involved with multiple proof of concepts. Our customers are involved with multiple proof of concepts, and we definitely see this NFP and SNDN starting to ramp up in the 2017 all the way to 2022 realm. Key drivers, it's really the low-hanging fruit or some of the key aspects today. One is things like virtual IMS, the convergence of IMS technologies into a cloud environment, a cloud RAN or a virtualized radio access network, putting that onto a server-based and Intel-based environment, and virtual CPE, which enables the operators to provide customer premise services, things like security, DPI, voice over IP services, firewall protection for enterprise class businesses from small, medium, even to large size businesses, where they don't have to go out and buy the equipment, maintain it, and it saves the end user a lot of dollars. Also, a key market driver that I've been focused on that MICA plays a big role is mobile edge compute, especially in a 5G arena. So 5G is the new buzzword we're all hearing, and with that buzzword, we're seeing a tracking of 5G proof of concepts actually starting to happen now, even before the 3GPP standards are put into place. But overall, the key driver of 5G for us, our value statement and our strategy is focused not up in the telco data centers or in the cloud itself. We're really focused on the edge compute technologies. These are the technologies that live into the central office. They live at the radio tower itself or at the customer premise, anywhere but the huge data centers that are out there. And if you think of the value of 5G, especially in the IoT space, you have two high-level characteristics. One is needing the ability to support the capacity of all of the IoT elements, the machine-to-machine elements that are out there. Things like smart buildings, wearable technologies, energy management, traffic management, all of those key things that will increase the capacity needs of the telco market. You also have another area which needs really high capacity, low latency, high bandwidth technologies, very, very low latency. Things like video caching, video security, content delivery, connected cars, augmented reality, things that really increase the pleasure of the user's experience, the quality of the user's experience, and also maintaining a well-rounded system. A lot of these technologies really cannot live up in the cloud. They cannot live in the cloud, so they're going to live more as the industry call it, the fog. So you have the cloud up in the data centers and the fog being more close to the edge. There's even a term called mist, which is, the actual IoT sensors themselves. And we're actually delivering this. So we've been involved with mobile edge compute since really day one, since Intel and Nokia and others really started getting involved with the ETSI standards. We've been involved with day one. And we really are seeing a lot of the NFP, SNDN, MEC, and 5G starting to converge together. And it's a great footprint for mobile edge compute and fog capabilities. We know that these proof of concepts are going to go for a long period of time, so we're in it for the long run. We also see NFP and SNDN as kind of a foundation, especially when you're looking at the virtualized applications that'll be running. And we're also seeing a huge ramp up of SDN with container technologies being at the edge. So we see that foundation as being a must, and we also see that low latency and carrier grade capabilities on a common platform is also secondary and a must. And where we're moving to and where our product portfolios are focused on is because there's a convergence of the network, both for IoT, NFV, SDN, MEC, all those acronyms. We're seeing a key-driven opportunity for common platforms. These common platforms are reusable in that space, whether it's a data center, a central office, an open compute platform environment, or at the edge itself. And having common elements does a few things. One is it saves the overall cost of the gear. Because it is off the shelf, it's an open architected system, which I'll go into more detail. And it's reusable across all those multiple facets. Data centers, are mainly AC power. The cooling is done differently. The size, the shape of the chassis are much different than central offices. Central offices, you have certain telecom carrier grade capabilities. You have DC power, front I/O versus rear I/O, NEBS compliancy. All those type of things are different, but with a common platform and reusable sleds that meet all of those environments is really the true facet of the technology that MICA delivers. Where MICA, the DNA for MICA came from is Intel and through network builders and its partners, came up with a lot of rack scale based architectures, RSA being one of the first ones, then open frame technologies. So the DNA from the Modular Industrial Cloud Architecture, MICA, started from Intel and us building a system on a Lego building block reusable type sleds. These sleds can be, again, reusable in different environments. There's a common mid-plane or back-plane technology using PCI Express. There are interchangeable sleds, like for instance with MICA, you can use E3-based Xeons versus E5 Xeons, I/O sleds. A lot of the different characteristics that are used for different types of applications and solutions. So back in 2014, we kind of put our heads together, came up with it. Intel basically gave us the IP. We ran with it. We made some changes within the mid-plane. There was some major issues to overcome. We took that challenge, and we have a new product that does this. PCI Express, multiple facets of CPUs, even ARM-based processors, things like Rapid I/O, 64-bit type processors can be included, I/O storage. The whole gambit can now be put into these type of chassis and architectures. So Modular Industrial Cloud Architecture really stands for three key things. One is it's modular. It's modular in nature. It's decomposed of both software and hardware that can go across the different CPU processors within the chassis or within the system. It's decomposed of different hardware resources, things like compute, storage, network I/O, other areas, other silicon technologies such as ASICs, ARM, again, Rapid I/O. And our focus is, again, for this type of technology can fit very well in the data center, but it's really focused more on either customer premise data centers that are owned by the operators, central offices, cabinets, environments that need a common platform for multiple use cases. Normally delivered at the edge of the network, the MEC or fog. Industrial is the carrier-grade aspects. These are the common elements need to be able to withstand things like earthquakes, high heat, low cooling, areas that are beneficial for carrier-grade, the 6.9s that are looking for, especially for real-time high performance and reliability. We know as we move more into the telecom cloud that the containers and also the virtual machines can be built up and brought down on an as-needed basis, but having an industrial component allowing that hardware to do the same is a requirement that we're hearing from our customers. And the cloud, again, it's the hardware accelerators to burst that virtualization, increase the application performance, especially in a public or a private cloud environment. And we're really focused on that telco, MEC, and fog environment for MICA. To let you know the product, so now we're going to take a look at the actual product itself. So I've kind of set a foundation. We got converging markets out there. We got common platforms. We've got this MICA-based product that's focused on the multiple environments. So the hardware itself that we have today, we have a mix of Intel-based CPU, what we call sleds, and these sleds are in both half-width format or quarter-width format, depending on the amount of density the customer requires for CPU processing. We have a Broadwell-based sled that has two Broadwell CPUs. We have a Pearly that's coming out at the end of the year, which is a Skylake-based processor. We'll also support Pearly with FPGA in the first quarter of next year. We also are one of the first companies to provide the Skylake GT4E Intel CPU that really conforms and is focused on the media processing element. We have a quarter-width sled with two CPUs on there that really provides that density. We also supply a host of switching solutions because the system relies on PCI switching and also outbound Ethernet switching. We have a Red Rock Canyon, which is a switch produced by Intel. The best thing about Red Rock Canyon is it's a hybrid type switch. It does both Ethernet switching and also PCI Express switching with capabilities into the 100 gig, which is kind of a requirement with LTE and, of course, 5G capabilities. We're also coming out with a Broadcom PEX switch, which allows nothing but PCI switching. And we're also doing what's called MRIOV, which is the SRIOV for memory and storage. So it's a better allocation and better use of PCI switching and memory capabilities. We'll be announcing this at the end of the year with delivery in Q1 next year. And we're working with different silicon providers as well for hardware accelerators, custom ASICs, and things like Rapid I/O for 5G networks. Also, as I mentioned in one of my earlier slides, we were talking about security and deep packet inspection. A lot of companies, they're looking for products with a tremendous amount of I/O capabilities because what you call a bump in the wire, and a lot of times the system itself, the hardware capabilities are in line with the flow of traffic. So you need a lot of I/O capabilities. So within the MICA system, I have the ability to plug and play different I/O sleds along with the different switching sleds and, of course, the CPU sleds, all within a 1U, 2U, 4U, all the way into a frame-level environment, using those common elements in this picture from the system level below all the way up. So I can put this into a small system. It's scalable to extra large systems. I can put this into a data center. I can put this into a central office, all using the same type of SLED architectures with a really solid roadmap going forward. And the key aspect of the system that both Intel and ADLINK has really created is a common motherboard environment that can be created as a SLED, and that SLED can be put into a system that's developed specifically for a data center, 21-inch frames, very deep, 1,000 millimeter deep, or into a central office, which are like 19-inch frames and 800 millimeter depths that need NEBs or DC power, interchangeable power modules, interchangeable IOs, even into an OCP telecom environment that I'll talk about soon. Also, we have an open SLED environment for open frames as well for these CPUs. One of our systems that we have available, and we're actually going to be showing this at the upcoming Carrier Virtualization Show in Palo Alto in December. We've shown this in some other shows as well, which is a 4U, what we call a network appliance. And again, it uses those common SLEDs, that common architecture of plug and play with a Red Rock Canyon switch to enable a standalone appliance system to do things like NFP, SNDN, MEC, IoT capabilities at the edge. Lots of a fabric up to 1.3 terabit of total bandwidth. And we have a host of IOs that you can support from 1 gig to 10 gig, bypasses, optical bypasses. All of these are interchangeable between the 7400 4U system or a 7200 base system, which is a 2U environment, which is what I'm showing here. This is a great interchangeable system for things like security and deep packet inspection, where you have a common CPU SLED with many IO SLEDs for that bump in the wire environment. And again, all the SLEDs are interchangeable between each system. We also have a data center system, which is really focused on more that media processing. It's called the 2080 next generation MICA system. And it's, again, I can interchange my E3s and my E5s. I can have nothing but E5s or E3s. And this setup, lots and lots of the Skylake E3 capabilities, lots of density, CPU density. It's deep. It has a PCI expansion slots. It has the I/O that goes in the back, which is a lot of times what's required in the data centers. And the cool part about these systems as well is I'll talk a little bit about ecosystem, but because the chassis is primarily sheet metal, we have a large realm of ecosystem partners, and even us as being a manufacturer, we can put these in things like media trucks. We can put these at customer premise, where those SLEDs are all the same. The big activity that we're working on now is we are a gold member of Open Compute Project. A lot of folks have heard OCP, mainly because of Facebook and Google on developing, off-the-shelf server software and hardware specifically for their data centers. And the telecom environment is really looking at something like OCP as they start migrating their central office switching gear, such as MMEs, serving gateways, packet gateways, policy enforcement servers into a telco cloud. The operators are sitting on a nice piece of real estate, and that real estate, the central office, they would like to do the same thing as Facebook and Google has done with common off-the-shelf hardware, common off-the-shelf software that can manage it versus all this proprietary built gear in those systems. So OCP Telecom is really driven by the operators. It's a collaborative environment with a multi-host of suppliers such as ADLINK and the operators worldwide, Telefonica, Orange, Vodafone, Verizon, AT&T, and others that are looking for that reusable infrastructure. And what a great environment for the MICA system to be able to fit not just as a single appliance, but also fit directly into an OCP-based standard. ADLINK is heavily involved in standards institutions. Our true belief is not to have a proprietary-based product, but really believe in an open architected product. Things like ATCA, compact PCI, VPX for military systems, OCP, TIP, telecom infrastructure platforms and projects. So we're really, really into this open architecture, which is really the benefits of MICA. And what we're doing with MICA is one of our key partners called Radisys. They have an OCP telecom frame environment that they have submitted into the OCP telecom, which includes the environmentals, the power, how these things called pods, which are really kind of the sleds but in a pod environment, slide into that telecom frame. And our specifications that we're working on is having the ability to take that common MICA infrastructure and build that into these pods that will fit into this OCP telecom frame. So that enables the operators to not just have a single appliance, but actually have a frame-level appliance or appliances that fit into their OCP frame. Our benefits that that MICA has done as a single appliance, things like PCI Express, the multi-use of sleds in different environments, the plug and play, we want to actually bridge into this OCP telecom. And what we've done with MICA and OCP telecom is we're developing this pod layout with different zones. So you have zones 1 through 6. You have fans, power, the mid-plane, where the environment for your CPU, memory, and storage, and also your network interface module, which is optional, that allows different interfaces versus the top-of-rack switch that may be used in the OCP. This will be done in an open rack OCP telecom carrier-grade environment as spec'd by Radisys. We'll be using DC power as that spec shows. There's an easy OCP connector bus, as you see here in the back, and optical cable port connectors that go back to the top-of-rack switch, or you can put in our own switching capabilities, and this pod will be a self-sufficient appliance within that OCP rack. And that's going on right now. We'll be submitting that spec within the next month, working with our sponsors, which are things like Verizon Wireless and Telefonica and Radisys and Intel and, of course, the OCP team. And we'll be presenting this at the next OCP conference. To let you know where we're at with MICA and our other mobile edge compute products is we are in multiple proof of concepts, and we have such a great ecosystem of partners. Intel is great. We're working with the Network Builders team. We're working with Intel on the common CPU architectures. And because we are a premier partner, we get a lot of early silicon. We come up with these designs like MICA with Intel. We cross-market, cross-reference with Intel. And also, one of Intel's key subsidiaries called Wind River, we actually embed the Titanium server software within our system, specifically around NFP and SNDN. We are also working with Nokia, which is a key Tier 1 customer that is delivering some MRIOV capabilities. In that NFE environment, we have the ability to drive NFV and SDM through KVM and Wind River along on Intel-based processors. So this is going well, and we're continuing to see these proof of concepts expanding. We also have a great roadmap. This product is not just a one-time thing. We see a nice long life cycle of the product. And because we are so involved with the industry standards, we have a good insight into the future. And because a lot of our customers are TIMs or carriers, we have to deploy products, years in advance before the systems go live. So with our ecosystem of partners and with our standards that we're part of, We have, we'll continue with the TikTok of Intel-based CPUs. We're working with IDT on rapid I/O technologies, specifically for video and 5G networks. We have some ARM-based processors, specifically around the IoT environment, sand blades, other type of storage solutions, velocities, stack velocity, new ISIS, others that we can build storage sleds within the system. NVIDIA for GPU-based systems, that are heavily reliant on video. And also different system levels, from frame level to 3U, 4U, 6U, 9U appliances. Also working with Intel on photonics backplanes. How do we continue to increase the backplane performance? And then, of course, platform software and continuing to expand our software partners. Also, when our customers buy our systems, there's an expectation that it's proven technology, that we've proven out the performance, we've proven out things like open source and OpenStack software. So we have an environment really worldwide that we work directly with our customers to test, provide, and deliver middleware from Wind River, an acquisition that we made, Prism Tech, another key partner, Saguna and Mexware for mobile edge compute software for middleware. Open source, from Redfish to OpenStack, Open Daylight, Open Nano. We validated all that. We also have a lot of key ecosystem partners from a virtual machine or a container perspective, from security, virtual CPU, analytics, media, and NEC applications. All running on this common platform called MICA, and also our mobile edge compute platform setup. And with all of the open source and all the different characteristics that our customers are looking for, we have innovation labs that are being planned out. Our San Jose will be done first half of next year. Our Shanghai, China, because we have a lot of China, like China Mobilecom and others, ZTE, we're building a very significant facility within Shanghai for innovation lab. And what that does, it enables our customer base to easily port their virtual machines on different environments in MICA. It allows them to bring their own customers in to look and test products on MICA. And also we have the ability to provide virtual network function performance and reliability results, all within one lab. And we'll be expanding that into Europe and other areas within Europe as well. I won't go into great detail. I think most of the folks on the call probably understands the NFV and SDN functions, but what I wanted to stress here is that we have the ability to pre-integrate the NFV and SDN software system that's being delivered by Wind River into the system. That provides our end customers what we call one throat to choke, that we have the software pre-integrated, so we support it, we deliver it, we license it all to the end user, and whether that end user is a carrier or a TIM or a true end user, we have the ability to do that on each individual sled for MICA and our mobile edge compute box itself. We also provide our packet management system, which goes across control plane and data plane capabilities. Also goes across different silicon, whether it's Intel or Broadcom or Cavium. But we also really heavily rely on some of the DPDK attributes, because we're such a great partner with Intel that we really get some of the early software attributes of DPDK, Media Studio, and other types of tool sets, especially coming up with FPGA. From Intel, we'll provide all these different tool sets, tool packages, SDKs, programs directly to the end user, and with a nice support staff behind it. Because our MICA system is considered an open architected system, what we've developed is a very strong alliance partnership with different technology providers that are out there, from middleware to application partners to integration, testing, support, silicon and whatnot. And with this gives you the ability to take a common system or common platform like MICA and customize it to your need, or if you have a vision of who has been tested or validated on your system, we can deliver that as well. Things like security from Clavister, Trend Micro, Fortinet. We can deliver middleware from PrismTech for IoT specifically, or IBM for IoT, or Wind River for NFP and SNDN. We can do RAN technologies through Tieto. We embed Tieto software within our systems. Saguna, a huge player within the mobile edge compute environment. We can embed their middleware for virtual RAN or open RAN environments. Analytics, NetScout, and others that we can actually provide. So, and this alliance is growing, and we go in, especially with our partners, to these carriers who need help in developing and driving these type of common systems, and we can provide that overall architecture. So to wrap it up, what is it? So, MICA, Modular Industrial Cloud Architecture, is a flexible, modular, open architected system, reusable sleds in different environments. These sleds are common. You can mix and match sleds in these different environments, whether it's a data center or central office or an OCP. We embed NFV, mobile edge compute, fog, SDN-based software pre-integrated within all of our systems. So it provides you what we call an operational ready system versus the end customer having to put us all together themselves. And it definitely reduces the time to market and also the total cost of ownership, especially when you have one throat to choke, which is ADLINK. We also focused on a nice roadmap for OCP telecom, additional technologies like photonics, other switching components, things like MRIOV. We're also focused heavily on packet management systems with DPDK, with Packet Manager, Media Manager for video analytics, video processing. And with this operational and application-ready cloud platform, we're building these innovation centers out. We're building out MICA with, again, this long subset of functionality. And Renee, that about does it on MICA. I think I basically provided a good overview of this brand new great product that we're introducing.
Thank you, Jeff. I think you did a really good job too. We do have a couple of questions here that have come into the audience that I would like to ask you. What is the key differentiation of your OCP specs, the telecom group? When will the spec be ready?
So as I was saying, we're a true believer in open architecture, and OCP was really developed mainly for the data center environment. It was built really for Facebook and Google's. It's an open spec, and where we see the key differentiation of our product is it's going to fit very well in that telecom office. And because we have great sponsors like Intel and Radisys and Verizon and others, building that CPU pod on reusable architecture that can fit not just in an OCP frame, but as a standalone appliance or in a data center or at a customer premise, saves money, saves value, and it provides a great common platform for all of those different environments. And because it's not proprietary, we're providing the pinout configurations, the mid-plane, and by allocating the zones in these pods, anyone can actually build within the spec their own product within that environment. So we see that as a key differentiator that benefits the operators and the end user.
Thank you, Jeff. When will ADLINK deliver Intels Pearl with FPGA?
Of course, Intel bought Altera, and Altera's FPGA program is really critical for especially custom environments like for media processing and moving away from generic ASICs onto a field programmable gate array. Because we're early adopters of Pearly, and we're actually delivering this early in the field. We have 1 to 2 key customers that are looking at this FPGA technology. We should have early samples by end of year with proof of concepts coming out in first quarter of next year. We are working directly with Intel and Intel's FPGA group and their product team with Owen. We also have some other third parties that are providing additional FPGA components and support based on a geographical subset. So hopefully we'll have this up and running in first quarter, and if there's any opportunities or any interest in the Pearly with FPGA, I'll ask the audience just to contact us through this webinar for the network builders.
Thank you, Jeff. Do you see a ramp of media services at the edge?
Yeah, Renee, that was a good question. So one of the key attributes of mobile edge compute really kind of started off as how do I improve or optimize my existing network from a telecom environment. When you have 4K services, heavy video usage, it's starting to put more and more of a strain on the backhaul environment, especially with it's so clear that the operators need to rely on quality of experience for the users to retain those users on their network. So by putting more and more video services in the central office and at the edge, provides that quality of experience, the quality of service that these users are demanding when they're watching, whether it's a movie or a short YouTube video on a how-to, video surveillance, and those type of items, versus putting that into a data center. And it's not as easy as people think as well. You have to have key components that make up that video server, media server. You have to have key software components, the middleware that's reusable across your network. Things like Saguna, PureApp, Mexware, and others that provide that infrastructure that's pre-built into our system is so important. And we're delivering it today. Again, the future is here and it's now, and we're delivering it today.
Thank you, Jeff. I just have a few more questions for you.
Okay.
You mentioned Wind River Titanium software. What is ADLINK doing with the Intel Wind River?
So we created a great partnership with Wind River well over a year ago, specifically for Titanium. We've always used Wind River, some of their carrier-grade Linux, as operating systems. Where Titanium servers coming into play is taking that open stack, that open source environment, and really carry grading that environment, robusting it, building on top of that ETSI NFV software infrastructure. So Wind River has done a fantastic job on taking those common elements that are created by ETSI in an open source, building on top of that carrier-grade attributes, things like in-service patching, in-service upgrades, vSwitch acceleration, flight recorders, a great GUI interface, and also kind of providing those APIs that make it easy for the operators and the end users to create those application virtual machines on top of NFV. And we see a great roadmap with Wind River Titanium. We see the SDN starting to take off more and more. Actually, we're seeing more and more SDN taking off than NFV with containers. And Titanium is a great platform with that. And again, we believe in that open architecture. We believe in a common platform that can be reused, and the Titanium server is perfect for that. And we're continuing on with additional opportunities with Wind River and jointly selling and jointly marketing both of the programs. So again, Wind River is a great partner, and we see that continuing to grow.
That's good. Thank you, Jeff. I have one more question for you. You mentioned support of NFV with the MICA systems. Can you provide an example of proof of concept you are presently in?
Yeah, we're actually working with Nokia. So Nokia is a pretty major TEM that's out there, and with Nokia, we're doing some NFV proof of concepts in Europe using Wind River, using our packet manager, and on our MICA system. We're also working with China Mobile on an NFV solution as well. We're working with PureApp on doing video caching, video analytics for some operators within Israel. We're working with Saguna on their Open RAN technology. We're also working with Mexware on some mobile edge compute Open RAN environments with Vodafone. So we're part of many, and that's only to name a few, many proof of concepts with the MICA system and our ecosystem of partners. And the overall feedback that we're seeing, Renee, is that having this system interchangeable and also with our ecosystem of partners provides additional value to that end user because they're confident that that product will work because we've validated it, we've tested it. They're part of either the network builders environment or the Titanium Cloud environment, or we've pre-validated on MICA. It provides that confidence level versus them going in and having to do it themselves. So the initial feedback is very positive, and we're coming out with, again, with the Pearly with FPGA. We're seeing some good opportunities there. We would love to get, more proof of concepts and market feedback on FPGA along with Intel. So I see definitely a very bright future in these proof of concepts going to a true ramp and live environment.
Thank you, Jeff. Jeff, I'd really like to thank you and the audience for taking the time to be here with us today for this presentation. It was very informative, Jeff, and I appreciate that. Thank you. That's the end of our presentation and our questions. If anybody has any future questions, you can still ask them through the recorded version, and Jeff can follow up with you via email. I would like to thank everybody for their time, and I hope everybody has a good day.
Thank you, Renee. Thank you, everyone.